That way we can get this done. All right, functions. This is just the first part of this lesson. Tomorrow we'll learn the second part of functions. And let's just write our basic definition for what makes a function a function. It is a relationship between two variables such that each value of x, and x is known as your independent variable. A relationship between two variables such that each value of x, your independent variable, there corresponds one value of y, which is your dependent variable. A relationship between two variables such that each value of x, there corresponds one value of y. And at the same time last year is when you learn functions, literally in pre-calculus. I'm doing it right now with pre-calculus, okay? And there were like three ways that a function is a function, okay? Your x's can't repeat. You got to pass the vertical line test, or if you solve it for y, it shouldn't assign two values of y to one x, okay? Because that just means your x is repeating, essentially. So the first part of tomorrow night's homework will say determine if y is a function of x. And let me just give you 4 different kinds right here. Determine if y is a function of x. So your first thing is, obviously, what you want to do every time to just determine if it's a function, just solve it for y, first of all, because that'll kind of give you a good visual of what it looks like. You can put it into your calculator and look at it even more so, but, just solve for y. Solving for y should be your best friend by now. So if I look at this right here, x plus y equals 1, and if I solve that for y, I would get y equals 1 minus x, right? What kind of function is that? What does the graph look like? A line. It's linear, okay? Are lines functions?
Yes.
All of them?
No. All of them except for one. No.
All of them?
Except for straight.
Except for verticals. That's exactly. All functions, all linears are lines, are functions, except for the vertical ones. So if you have a line, a linear, we have what's called a linear function, but just give yourself a little note, except for verticals, because vertical lines obviously fail vertical line test. Okay, so linear function right there. Perfect. What's this one? You just had a quiz on it. What is this going to make? Going to make a circle. Are circles functions?
No, they don't pass the vertical line.
They don't pass the vertical line test. You go right through 2 points. Okay, so if you were to solve this for y, though, you get y squared equals 1 minus x squared. You take the square root, and again, what do I put in front of that square root symbol? So what that does is, this plus or minus is assigning two values of y to one value of x. That's all right. So if I said x was 0, then I would get an answer of positive 1, or I would get out negative 1. So it's like, well, which one? I am actually having x's repeat with different values of y. So this is not a function. It assigns two values.
Isn't it because the y is plus and minus? Not because the x is plus and
minus? Yeah, the y is plus and minus. But you're plugging in a 0 and you're getting out a positive 1. And if you plug in a 0, you're getting out a negative 1. Well, which one is it? You're getting two values of y assigned to that x value.
Yeah. Right.
Except I did.
That's okay. Just go ahead.
Anybody know what this one is if you solve for it?
No, it's
Yeah, it's a parabola. It's a quadratic function. Yeah. And just so you know, all quadratics are functions. I just wrote quadratics function. That's all right. Okay, quadratic functions are functions. So that's easy. That one works. What about this one? Do you remember this one from last year? What's this one? Yeah, okay. Well, it actually is this way, the square root one, and it's its reflection. It's actually a sideways parabola when the y is squared. And again, if you go to solve for y, and you take the square root, you're going to get that assigning two values to this value of x here that you plug in. So this one is not a function. This is a sideways parabola. Now, all of these, obviously, like once you solve it for y, you can put it in your calculator, and then I would do, just to double check if I could, I would check the vertical line test. And let me just show you some, pictures of that. There we go. Yeah. So which ones are my functions, which ones are not?
One is a function.
1 is a function, 3 is a function. When you fail the vertical line test, it's because you hit it twice. Okay? You've assigned, this x value has been assigned two y's. We don't want that. So that is not a function. Same thing over here. You hit it twice, not a function. Okay? So easy to tell if you have a function or not a function. So that there will be this on the worksheet today that I give you. It will ask if it's a function or not a function. It's pretty easy. The second part of the worksheet today is what the main part is domain and range. And so we're going to go over all that again. And that's where, again, Andre schooled me last year. It has to be said. It must be known. I'm a person who can own up to my mistakes. Sometimes, on occasion. Your domain and range, okay? So, like, the kind of brief way of saying this, because I don't really want to go into the full way, but domain is really like, I say, how wide is the picture? How wide is the picture getting? Okay? From the left to the right. How wide? From left to right. You always want to go small to big. It's your x values. Always, always, always give me x values for domain. Don't give me the y values. Tell me what on the domain, on the x-axis. We did this a lot last year, so you should remember how to do this. Range, how tall is this graph getting? Up and down, okay? And again, those are your y values. So just make sure you know how to do this. So we're just got 3 examples to do, and then I'm done. We're over. So if I said y equals square root of x plus 1, what's that look like? Without your calculator right now, let's see if you shift it over where?
To the left one.
Nice! You're brilliant. Okay? Now remember, that it looks like it's flattening out, but it really isn't. It's the square root curve actually does curve, and it goes, and it keeps creeping up ever so slowly, but it is still curving upwards, okay? So if I asked you then the domain, and I think I did this last year because I just did this with the pre-calc. Domain again is how wide is this picture getting? Well, it looks like from here, and that arrow just means it keeps getting wider and wider and wider, right? So what would you say? Where would its starting point be? To where? Infinity. Okay, so you're going to say bracket -1 to infinity. Open parentheses. Because we got to use interval notation now. the range would be how tall is this picture getting? And again, don't think it's leveling off. It's ever so slightly creeping up, creeping up, creeping up, creeping up, okay? But where does it start on the Y? 0 to where? So there you go. Easy breezy. Let's do, though, for number 2, a good old-fashioned piecewise. Good kid, good kid. That just warms my heart every day. It really does. I just love him so much. He's growing up so fast. All right, now, I will let you put this in your calculator. If you don't remember how to do it, write this down, okay, so that way you can go back in your notes and look at how to do it in your calculator. You would put this top function right here into the y1, okay, and you type 1 minus x. Don't type the comma. Hit the division symbol, then hit parentheses. Do you kind of remember this? Then x. Do you remember where the less than symbol is located? Second math. It's the test function is what it's in, but I'll write down second math. Hit the less than, then hit 1, and then close the parenthesis. Then this one you do in y2, and you do the same thing. Square root of x minus 1, don't hit comma, hit divide, parenthesis, x, second math, 1. But, I mean, again, you all should pretty much, I hope, know what this looks like. You're for x less than 1, here's 1 on the x. Isn't that a line, correct? It starts at 1, it has a slope that's negative, so it's going like this. Okay? Then this one, you just did it before over here. This is a square root. Shifted over to the right one, so it's going to go like that. So if I asked you, I mean, you can check for me right now on the calculator, but if I asked you what is the domain of this function, how wide is this going? From where to where? Yeah. Range, however, again, now there is a range value here because the picture only goes as far on the y-axis as this, but it still keeps going up. So what would you say on the y from where to where? 0 to infinity. And it is a bracket there, okay? And then one more, and we're done. F of x equals 5 over x plus 2. Okay. We graphed these last year. Okay. And again, you can graph these if you want to. But just so you know, again, with fractions, your bottom is what we call the vertical asymptote. Other functions. The vertical asymptotes. Okay? Holy shit.
Oh!
Do you remember?
So close. I said
Did you? Okay. This is your vertical asymptote. So we have problems in the bottom. I mean, where is that problem at? Where's the x problem at? Where would this become 0? Okay, so that x cannot be negative 2, or else I would make a 0. So there's restrictions here. That, my friends, if you don't remember it from last year, that is your vertical asymptote at negative 2. Don't want to touch that. Okay, that's that special little asymptote. Then you've got these hooks happening. Okay? And the hooks are going to go like that and like that. Okay?
Oh, yeah.
So when I talk about the domain then, about how wide this is getting, well, there's a picture here, and then there's another picture here. There's actually 2 pieces again. So from this side to this part of the asymptote, you would say from negative infinity to, again, where's that problem at?
2.
Negative 2. You would still say negative 2, you just leave it open. Okay, don't say negative 1. No, because there's still numbers there, like negative 1.999. You can still be. Okay? And then you just go united with negative 2 to infinity. So that would say to me, the domain is totally fine except for negative 2. That's what that is right there. Okay? Wherever the problem area is.
the range, there is not just a vertical asymptote, there is a horizontal asymptote to this one. Do anybody know where the horizontal asymptote is? 0 on the y. So guess how you write your range? Negative infinity to 0 united with 0 to infinity. Okay? So that is like the one challenge that you would see today. All right, so homework tonight is this domain and range worksheet, which you have, 20 minutes to do. You can work on that. You can work on the ISL. I'll give you the sheet right now. My throat. Help me.